All right, so the main difference between these problems and the ones that we have done previously is that we're putting function notation into the mix, and that's about it, okay? So we're letting f of x be equal to 1/4 x squared minus 4x minus 5, and g of x equal to 1/5 x plus 2, and we're being asked to use graphing technology to determine the following. So what do we want to know here? We want to know what the points of intersection are of f of x and g of x. We want to solve f of x equal to g of x, solve f of x greater than or equal to g of x, and solve f of x less than g of x. Okay. So the first thing, of course, is to get both of these functions entered into Desmos and find their intersection points, right? That's our first question. So let's do that. So the first function that we're going to enter is f of x equal to 1/4 x squared minus 4/3 x minus 5. Okay, so that's f of x, that great big blue parabola there. And then g of x, what did we say it was? 1/5 x plus 2. Okay, so again, I'm going to shift this a little bit. Depending on the device you're on, you might want to zoom in or zoom out a little bit. Make sure that you can see the key features of the parabola as well as the intersection points, right? Those are the important things. And if I click on the intersection points, they will be given, okay? And I notice these aren't nice integer values. Very often they won't be. That's okay. All right, so let's take this graph and its intersection points and see if we can answer the questions that we've been asked. Okay, so about this original question, what are the points of intersection for f of x and g of x? So I would list the points. Of intersection as negative 3.049 and 1.39, right, for the first point of intersection, and the second point of intersection 9.183, 3.837. Okay. All right, so now what do we want to know? We want to solve f of x equal to g of x. Okay, so when those two functions are set equal, their solution are going to be the x values of their intersections, right? Well, we found their intersections. We just answered that question. What are the intersection points? So the x values of those intersections, negative 3.049 and 9.183. Again, just to say this in a different way, when x is equal to negative 3.049 or when x is equal to 9.183, if we stick either one of those x values into each one of these functions, the output, in other words, the y value of the function will be the same at each of these values, right? For both functions. So now, when it says solve f of x greater than or equal to g of x, so again, we want to think about that as saying, okay, well, where is f of x above g of x? Where are the y values of f of x bigger than the y values of g of x? Okay, now remember, f of x is the blue parabola, right? It's the 1/4 x squared minus 4/3 x minus 5. And then the green line is g of x. That's the linear one, 1/5 x plus 2. Okay, so we're basically saying, where does the parabola lie above the line? Where is f of x greater than or equal to g of x? Okay, so I'm going to shade where that happens. Okay, since we have greater than or equal to, I'm going to put solid dots right on those intersection points. Okay, and if I want to know where does the parabola lie above the line, I'm going to shade the part where that happens, right? Out here to the left of negative 3.049 and then out to the right of 9.183, right? So that part that I just shaded there in red, that's the solution set. Okay, so how do we write that? State the domain of it. So the solution set is negative infinity up to negative 3.049. Okay, and we're using a solid bracket since we've got greater than or equal to, in union with 9.183 to infinity, right? Now, lastly, we want to solve f of x less than g of x. Okay, so now we're looking at the opposite scenario, right? We want to know where is the parabola below the line. And it's strictly less than. So here in purple, I'm going to put open dots around these intersection points so to indicate we're looking at part D here. This will be in purple. And I want everything that's below that green line, right? That's on the parabola. So I'm just going to shade the part of the parabola that's below the line there, okay? Less than f of x less than g of x. Okay, so that purple part that I just shaded, again, state the domain of it. So it's going to be an open interval from negative 3.049 up to 9.183. So hopefully you're getting the hang of this. Graphically speaking, where does one equation lie above versus below another, greater than versus less than respectively. Okay, so now I want to try some fun things with Desmos just to look and see what other power it has. Okay, so we could get rid of the function notation entirely and just write this as an inequality, but I want to see if we leave the function notation in it, what would happen if we said, okay, I want f of x greater than or equal to g of x. What does it do? Okay, it shaded it for us, right? So let me get our points there, okay? So we can see that it's shading that part where f of x is greater than g of x, the same part that I highlighted on that parabola. That's the part it's shading on the number line there, right? Less than negative 3.049, I should say less than or equal to, and greater than or equal to 9.183. Okay, so now if I went to less than, now it's giving me that piece where the parabola lies below the line, right, which is between negative 3.049 and 9.183. Okay, all right, so we can see how this works. And I kind of like having the function notation in here like this because you can see graphically where that line lies below, right? Because without having the lines actually in there, it's harder to see. I'll show you what I mean. If we don't graph them individually, as was the case in some of the previous examples of this section that I did, let's see, I'm going to take the function notation away here, and I'm going to take g of x away here too. I'm going to say if I have this parabola less than or equal to 1/5 x plus 2, that was the line. Obviously, if you graph both the quadratic function and the linear function separately, you'll see the graphs of them there, and if you just enter the actual inequality here, you don't see it. So it's not meaningful in terms of why this is graphically what it is, as we saw in some previous examples that we've done in this section. So just keep that in mind. Desmos is a very powerful tool and it can give you a lot of information, but do try to relate the inequality to the actual graph of each of the pieces of this, okay? So just a word about that. Desmos can do a lot for you, but make sure that you know what's going on there.